So this is a problem similar to the last one I posted, except now instead of ending up at point C, the boat actually wants to reach point B. So it's capable of going 24 meters per second, and the river's flowing south at 9 meters per second. Now we saw in the last problem that the boat aims directly for B, straight on, the river is going to push it down, it's going to end up at point C. So that is not going to do it, so we cannot just aim for point B. So we are actually going to have to fight the river a little bit here. So it's going to have to go up at an angle like this. So its speed is 24 and it's going to be up at an angle. Now in order to fight the river successfully, it needs to have a vertical velocity, or not really vertical, but upward direction on this picture of 9. Because the river's flowing south at 9, so the boat must be flowing up at 9 in order to counter that so it can get across to point B. So the real question here is, if it's using this much of its speed to fight the river, how much of it is being used to cross the river? What is its x velocity? And for this, we're going to have to use some trig. So if we go through this, we can use the Pythagorean theorem here if we like, call this x. So x squared plus 9 squared equals 24 squared. And just jump ahead here and solve that. So 24 squared minus 9 squared. I'll take the square root of that. And so my x component of velocity is 22.25. So that means that normally the boat could cross the river at a rate of 24 meters per second, but when it has to fight the current of the river, it is only crossing at 22.25, at least in the x direction. So what you're going to see is the boat is going to be aimed, it's kind of interesting, the boat will be aimed upward like this, up and to the right, but it's actually going to travel in a straight line. So the boat's engine is actually going to have to be pointed that way, but it won't move that way because it's just fighting the river. It's kind of a weird thing. So anyway, if this is the x velocity, well, delta x is 120 meters. And the x velocity we just said was 22.25 meters per second. So we're looking for the time needed to cross. So this is just a standard velocity time type problem. So Vx equals delta x over t. So 22.5 meters per second equals 120 meters over t. So we'll do our algebra and solve for t. And if I do that, I get t equals 5.4 seconds. So if there was no current, the boat could go directly across the river at 24 meters per second, and we found out in the last problem it would only take 5 seconds to cross the river. So this boat is going to have to use a little bit of extra time because it can't move as fast across the river as it would like, but now at least it's going to reach point B. If we're really interested, we could also find the angle needed to do this, because we know that the x velocity is 22.25 and the y velocity is 9. We can find this angle because we can say that tan of theta equals 9 over 22.25, and then we can use the tan inverse key on our calculator. So tan inverse of 9 over 22.25 gives you the angle. So just to do that real quick, this wasn't part of the problem, but it could come up. I get an angle of 22 degrees. So that means that this boat is going to have to angle itself 22 degrees north of east at this speed of 24 to make this happen. So just an extra additional problem for that, but it wasn't part of this. So anyway, that is relative velocity. It's all about vectors, canceling them out appropriately. We didn't really have to deal with the y as much in this case, except to figure out the x component. In some ways, I think this problem is actually easier than the other one we did, but that's just my opinion, I guess. So anyway, until next time, I am Derek Genova. Have a delightful day.